Unit 3, Part 3, continuing on with our demonstration that Steve believes that P is a non-truth functional sentential operator. Okay, so we have two input sentences with the same truth value where the truth value of the output is different. Okay, so we've got two true sentences. Steve believes that the first true sentence is true. Steve believes that the second true sentence is false, which shows that the truth value of the compound sentence, the sentence built with this operator, is not, the truth value of this compound sentence is not determined only by the truth value of the input sentence. If the truth value of the compound was determined only by the truth value of the input sentence, then the fact that they're both true sentences would imply that the truth value of the output is exactly the same. We're not quite saying the same thing as true goes to as true goes to true or anything like that, right? So you would not have, this is a mistake that people often make, you would not have shown that Steve believes that P is not truth functional by saying, look, here is a sample sentence, a P, that is true, but Steve believes that P is false. Therefore, since it goes from true to false, it's not truth functional. False. Remember, you've got to get a handle of the word truth value. Truth value is not the same as truth. Truth value is either true or false, right? And consider what I just said with regard to not P. Right? Not P takes any P which is true and makes it false, right? If P is true, not P is false. But not P is thoroughly truth functional, right? Because every true P is taken to a false not P, right? The truth value of not P is determined by the truth value of the input. True goes to false, false goes to true, right? There is a function. It's just that every single true input goes to a false output. That is what ensures it being truth functional. Okay? So, right, just going over it again, 2 plus 2 equals 4, that's true. Steve believes that 2 plus 2 equals 4, also true. We said Dan is wearing a blue shirt, that's true. Right? Dan is wearing a blue shirt today, true. Steve believes that Dan is wearing a blue shirt today, false. He hasn't seen me today, so he doesn't know, so he doesn't believe that. Right? So there you've got true input going to false. So this is really the summary, if you can expand it in your mind, right? Case 1, true going to true here. Case 2, true going to false here, right? That's same input, different output, understood as same truth value. Two sentences, different in content. They must be different in content because you need a different truth value output. But two sentences with the same truth value, but same truth value for those input or component sentences, different truth value for the component, for the compound sentence built with the sentential operator. And that proves that Steve believes that P is not a truth functional sentential operator. Right? See what we had here, this arrow was representing the truth functionality. Right? Truth functionality, the truth value of the input sentences determines the truth value of the output sentence. Right? Merely knowing the truth value of the input sentence, we can infer with certainty the truth value of the output sentence. Right? Same here. T goes to F. There is a function from. There is a function from this. This is like the x in y equals fx. There is a function from the truth value of the input to the truth value of the output. We have just shown that there is no such function for Steve believes that P. Thus, we cannot construct a truth table for Steve believes that P. Because what we're going to have is, right, when P is true, right, we just do this. P is true or false. When P is true, sometimes Steve believes that P is true, and yet sometimes Steve believes that P is false. Right? That was our first case and our second case. Right? When P is 2 plus 2 equals 4, P is true, and Steve believes that P is true. But when P is, Dan is wearing a blue shirt, P is still true, but Steve believes that P is false, right? So these divergent arrows contrast with this arrow here, or this arrow here. This indicates truth functionality. This indicates, these divergent arrows indicate the failure of truth functionality, okay? And it's because Steve believes that P and all such sentential operators are not truth functional that we are leaving them out of our entirely truth functional system of logic. Klenk writes here in chapter 3 that a system of logic is truth functional if and only if all of its operators are truth functional. And that's what's in sentential logic. Sentential logic that we're doing is a truth functional system of logic, right? Which will allow us to determine the truth value of every formula given merely the truth value of any component. That's why this is introduced in this chapter on computing truth values. It's the truth functionality of all our sentential operators, right? All the symbols that we have, right? All the formulas that we construct, is the truth functionality of all our sentential operators, which makes possible the computing of truth values. Okay, so let me give you a second example, proving that P after Q is also not a truth functional sentential operator. More than merely the truth value of the component sentence goes into determining whether P after Q is true. Specifically in this case, the time at which P and Q happened. That also affects the truth value of the output. Okay, so here it's a two-place, okay, here now, question, demonstrate that P after Q is a truth functional sentential operator. Sorry, demonstrate P after Q is not a truth functional sentential operator. Okay, P after Q, P and Q, you need two input sentences to construct a compound sentence, right, with this operator. So what the mantra, same input, different output, is now two pairs, right? Each one has to be a pair of sentences. You need two pairs of sentences where the truth value of the input in the pairs is the same in each case. For example, true, true, and true, true. You could also do it with false, 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 right? But then with the, so two pairs of sentences, right, with different sentences, because they need different outputs, or in this case we're just going to change the order actually, but two pairs of sentences with the same truth value, with the same truth value, so different sentences, different content, but same truth value, and then the truth value of the output is different, okay? So look how it goes, right? Example, right, the first sentence, one is Obama was president, second one, George W. Bush was president, right? What's the truth value of those two sentences by themselves? They're both true, right? So, but how about this sentence, P after Q, 1 after 2. So this is Obama was president after George W. Bush was president. Okay, what do we got here? Our input is true, comma, true. Obama was president after George W. Bush was president. Our output is true. Yes, Obama was president after George W. Bush was president. But look now, here's another sentence that's constructed with the blank after blank sentential operator. 2 after 1, that is, George W. Bush was president after Obama was president. Oh, that's not true. Both of the component sentences are true. Yes, both of the component sentences are true. So once again, we have T hook T, right? But the output sentence we built is false. That's it, okay? This here, same truth value input, make sure you understand that. That's the bit where everyone gets tripped up on in trying to answer this question. You've got two pairs of sentences, right? Same input, different output. What is the same input? It has to be same truth value input, right? You need two pairs of sentences where, for example, both of them are true, right? But where these two true sentences lead to a true input, a true output, sorry, where the output is the truth value of the compound sentence, the sentence built with the P after Q operator. And the second one, the two input truths go to false. Okay, so that, supplying those sentences, showing that true, true goes to true in case 1 and true, true goes to false in case 2, that is a demonstration of the non-truth functionality of P after Q.